Hello, my name is Michael Graff and I work at OpsumX, and I would like to talk about a project I've been working with called StormDriver. So about me, well, once again I work at OpsumX. I have some title there, not so concerned about that. I love to write Go code these days. It's quite nice and quite easy and quite small as a final product. I am on the Spinnaker Slack and I'm also on CNF Slack under my name. Feel free to reach out to me with any questions or concerns or ideally PR request topics. OpsumX provides SaaS solutions for Spinnaker and Argo CD as well as a number of other platforms. We do custom pipeline development and help you maintain that and so on. We also do on-prem Spinnaker support for both the open source and our own internal version. And we are quite happy to discuss anything with anybody who has any questions about that as well. So I want to make certain that I talk about CloudDriver first to sort of set the stage. And what is CloudDriver? CloudDriver is the heart of Spinnaker in that it is the thing that actually speaks to the different clouds and it pulls for infrastructure, and it also manipulates that infrastructure. It also knows about artifact accounts, and even though those are very unrelated, there's for example, a Git artifact account type, but there isn't a Git cloud account. They happen to be in the same service. It knows about all the accounts, so you can't shard currently without StormDriver using with different accounts. There is a way to shard CloudDriver, but I'll go over that in a little bit of detail about why that doesn't really scale so well. It can really consume memory. And it is written in Java. It's a standard part of Spinnaker. It's required, and it's automatically configured, generally speaking. So you can shard CloudDriver based upon the actions it's going to take. For example, you can have a caching CloudDriver component that all that does is query the cloud accounts and update its data and then send it to a cache. The caching response then comes back, and the read-only instances will then query that cache and get the data from there. So the read-only instances don't actually manipulate the cloud or look at the cloud, they only look at the cache. And this does separate concerns of types of actions, but every one of these still has to have the full list of accounts. In some cases, our customers have 5,000 accounts. If you have 5,000 accounts configured into Spinnaker, it's really difficult to do that with a single instance. It takes a lot of memory. So how do you scale CloudDriver or shard it so that you can have the account split? Well, you can't, and that's because CloudDriver still has to know about every account. Large pods in Kubernetes aren't a good idea. It's better to have many smaller pods than one or two large pods. And we've actually had customers who had to reduce features in order to make the CloudDriver fit on the nodes that they had in Kubernetes. It could take 32 gig, and maybe the node only has 32 gig, so they'd have to somehow limit that memory down to something smaller. It's also a problem in Kubernetes if you are the biggest pod on that node and that node runs out of memory. It really is likely it's going to murder that particular pod. So this division of labor, the HA mode, only gets us so far. So what StormDriver does is it allows us to shard per account. We still have a situation where the individual accounts have to be sized appropriately. They'll fit on a particular CloudDriver, but you could have a CloudDriver just for one account if it was a really big one. And we also notice over time, most people now have small accounts. They have large numbers of them. You might have Kubernetes with 100 or 200, or as one of our customers has 500 namespaces, each of which is a a Spinnaker account, and it just works. StormDriver is written in Go, and in my testing, I set up one CloudDriver that had 100 AWS accounts, one that had 100 namespaces in Kubernetes, one that had no accounts, just artifact accounts. The other ones had no artifact accounts, just the artifact accounts on this one. And the fourth one had a mixture of AWS and Kubernetes accounts, but no artifacts. And StormDriver, during normal operation, all my testing, took about 200 meg of RAM. it's written to be fast. So it's written not to interfere. It doesn't query each of the cloud drivers serially. It does them in parallel and combines the responses. So the memory footprint is really based upon the response size, the number and the total response size, and the number of simultaneous queries that are going to StormDriver. This is it. It sits in the middle. Orca, Gate, Igor, CloudDriver, and the CloudDriver source code are not modified, just the configuration. They're CloudDriver doesn't care who it's talking to, but Orca, Gate, and Igor's configuration is set up instead of talking to a CloudDriver or an HA instance of a CloudDriver, instead talks to StormDriver. And then StormDriver is configured with the URLs for the various CloudDriver instances. So why do this thing? Well, we need to break it up. When we have 5,000 accounts in a single CloudDriver, it takes a long time to start. And even if we turn off the runtime checking at the beginning, it can still take significant amounts of time to start. So a configuration mistake, for example, might cause a very large downtime. We would also prefer to have smaller pods for all the reasons I covered before. And the HA configuration isn't necessarily the best configuration. It doesn't necessarily add a lot of resilience, but it does add some complexity. So by removing that as a step, we find that since the individual cloud drivers start up faster and they run smaller, there's usually less downtime overall. So how does this thing work? Well, it maintains an internal list of credentials and artifact credentials by polling every one of the CloudDriver instances. And it does that every 10 seconds. And this is only for internal routing. So it polls using a user that's currently anonymous, but it's configurable. That user has to be configured such that it has full access to read the list of all accounts. It doesn't have to be able to modify anything, but the credentials response has to return everything. Same with artifact credentials. And this is only for routing. So we send that to everybody at once, all the different CloudDriver instances, and maintain that internal routing table. That routing table isn't used beyond internal routing, though it's not returned to the client or at any point. So how do we route? Well, we have a list of similar items. We have hash maps. We have single objects that we know the account is associated with. We have broadcast, which we don't know who it's associated with. We have pagination. We have post and put requests, in which case we have to, those are mutating requests typically, except for the put request for the artifact fetch, which is really a fancy get. And then we have unknown requests. So similar items are things like credentials and artifact credentials. We send out a query to every cloud driver that we know about in parallel, and whenever they respond or they time out, we then respond with the superset of the data. Forgive my dog. On the maps, it's the same idea. We scatter gather, send out the request to everybody, and combine the results. Singletons, we know who to send the request to. This is, for example, in this account, give me the details of this pod, or in this account, give me the details of this instance, VM instance. Then we know exactly where to send the request, so we can just route it directly there. In some cases, we don't know, so we ask everybody, and whoever returns interesting data, a non-empty response, for example, is the one we use. If we get back an empty object, we treat that as a possible response, and if we get back something better with something with actual data, then we'll return that. A common one here is tasks, where we don't track who's operating the task. So when we do a post request, we get back an ID, we send that to Orca. Orca will then poll. We don't know where that ID belongs, so we just ask everybody. It's fairly quick, so it doesn't really add much latency. And then there's pagination. I'm not going to cover pagination, but the API is a little bit strange, and so we just kind of punt on this. What we do is we limit the number of responses to 2,000, and if we get more than that, we just stop keeping track of them, and we send that response back. Typically, if a user in a UI, and this is used only in the UI, I believe, if the user in the UI is searching and they get back that many responses anyway, they're probably gonna type more characters until they get more narrowed down anyway. So this works just fine. And we don't do pagination. We send back 2,000, and if you ask for page 2, you get nothing. Posts and puts are handled because we know exactly which artifact account or which cloud account to send the request to, so we send it directly there. And unknown requests, well, we handle these differently. If it's a GET request and we don't know what the URL is for, we will pick randomly and send it to one of the instances. And it is logged, but past development time, I've never seen that log message occur. Unless I mistype a URL in the curl command manually, then I see it, of course. Post requests are handled, since they are mutating requests, post and put requests and delete and all the other HTTP verbs that can be used to modify state. Those are handled in such a way that we will reject if we don't know what that's for. This also includes CloudDriver accounts types that we don't know. Right now we support AWS fully, Kubernetes fully. I believe Azure and GCP work, but I have not tested those fully at this point. But those are the only 4 that Stormdriver currently supports. It's very easy to add others. I just don't have access to testing them. So security, well, the internal routing table that we use is never released. We use it for routing, but we don't use it as any responses. So we respect the Xpinnaker user header, which is set by all the other components, and it calls us with that header. We pass that header along when we do the scatter gather requests or the individual requests. That way, the RBAC model, we don't care about the RBAC model. The RBAC model is entirely within Spinnaker components, and the Spinnaker components can handle the checks just like they do now. Another really nice advantage of this is that we can use Go CloudDriver. And there's a little bit of information about it here. I won't go over it in great detail, but it allows us to use Kubernetes only CloudDriver, and it's written in Go. It's much leaner than the Java. It takes up much less time to do its tasks. It goes directly to the cluster instead of caching and having a delay. You can run multiple copies of it. It shares state through a database, so it's very resilient. And overall, it's just a much easier to work with Kubernetes only CloudDriver, but it does have limitations, and therefore we want to mix in. We have some things that we use the Java side for, and some things we use Go CloudDriver for in production, and this Stormdriver allows us to mix and match those and put accounts in whichever place we think is most appropriate. So our findings, well, once again, we haven't really been using HA deployments very much recently because it doesn't add as much value anymore. Stormdriver does add a little bit of complexity, but I think it's a lot simpler than the HA mode. You can also run multiple copies of Stormdriver, and they don't share state. There's no state that they have to maintain across them, so there's no coordination. We are able to mix in Go CloudDriver and possibly other other types of CloudDriver implementations in the future, and programming in Go is quite fun. So I don't actually have a demo. I have an anti-demo. And the reason I call it the anti-demo is because it's really hard to demo an API. So instead I'm going to show some traces. This is using Jaeger, and it shows the various responses. And those responses are, the orange responses are the important ones. The other ones are, the durations are valid, but the times are slightly offset for some reason. Probably because we're in a different time zone, and for whatever reason, it just seemed like the clocks were slightly off. But you can see that the overall query that Stormdriver issued here to fetch a list of credentials was 11.75 milliseconds. And the longest request from Stormdriver from one of the cloud drivers was 11.42. And that 11.42, it's only a few 0.3 milliseconds longer, so that's quite good. And this is the internal query that we issue, but overall the responses are very little latency is added. This is a real life example where Igor is asking us for a list of credentials. We had 3 milliseconds, and I'm willing to take 3 millisecond hit on a query like this in order to make certain that we get the responses properly. So where can you get this thing? Well, you can get it from github.com, OpsumX Stormdriver. It's an Apache 2.0 license, and I'm happy to take pull requests. Reach out on Slack, send me email, whatever you'd like to do, and I am happy to discuss. Thank you very much.